so if we've got this circle then maybe just recap you guys as well. So we're talking about finding the fraction of the circle, looking at the angle so that we can then work out the areas. What angle have I rotated around and cut here? So what's this angle? If I'm considering this part, what is the angle? Yeah, it's 180 degrees, isn't it? Right? How much of the circle am I taking if I take just this part as a fraction? Go on, say it again. Half. So 180 degrees would give me half a circle. Okay. Right, let's talk about the next image down here, which is 90 degrees. That doesn't look very good, but it is 90 degrees. All right, so let's say I've got that. How much of the circle do I have as a fraction? Quarter. All right, so we have a quarter of a circle. All right, now this is a quarter, but I'm actually interested in this side. So what angle is that? If this is 90 degrees, but I want this side of it, what's the angle that I have gone through? Yeah, good. So that's 270 degrees. So 270 degrees, what's the fraction? Yeah, good. 3/4 of a circle. Okay. Are you all right reading the colours, by the way? I was a bit concerned. No problems? Red on peach is maybe not the best, but all right. This then, if I tell you, all right, that this diagram is 1/3 of the circle, what would be the angle? No. Well, you've done well up to this point. What about someone else? There's 2 other people in the room. How did we know that this was 180 degrees? If we have half a circle, what do you do? Half of 360. How do you take half of 360? Same way you take half of anything. What do you actually do? Or another way of doing it. Say it again. By 2. Yeah, simple question. Yeah. No tricks. How do you find a quarter of something? You take the amount and you divide it by 4. How do you find 3/4 of something? You take the amount, you divide it by 4, but then you multiply by 3. So a bit simpler then. How do I find 1/3 of something? I divide by 'cause I divide by 3. So I've got to do 360 degrees divided by 3 and I get 120 degrees. So 120 degrees will give me 1/3 of a circle. Now, what I wanted to show you in doing this point is that if we use this angle, the 180, and we say, right, I have 180 degrees out of 360 possible degrees. If I think of that as a fraction and I simplify it, what do I get? Ninety over 180. Yeah, that is a first step, but it can go further. I mean, you could even say it's 9 over 18. You get rid of the zeros, but it can go even further. Is here. It's a half, right? So 180 out of 360 is a half. That's what we did. So here, for instance, if I do the same thing, 90 degrees out of my 360 degrees is the same thing as 1/4. Okay. 270 degrees out of 360 degrees is equal to 3/4. And 120 degrees out of the 360 degrees is the same thing as 1/3. So this is how we can use the angle to work out how much of the circle I have. So if I have 180 degrees, I know I have half a circle. If I have 270 degrees, I have 3/4 of a circle. All right. So how does that help us? Well, if I've got half a circle, all right, if I've got half a circle, I also have half the area. If I have a quarter of a circle, I also have a quarter of the area. Okay, 3/4 of a circle, I have 3/4 of the area, and so on. Yeah, so I have 1/3 of the area. Now, does anyone remember what the formula for the area of a circle is? Yes. So the area of a circle is equal to pi r squared, where r is what? The radius. Okay. So when I look at that, if I want to know the area of the segment of the circle, if I know the angle, I know the fraction of the circle I have, so I can just use that. So the area of this sector, sorry, I'm getting confused. I would just have 1/2 of, so multiplication is of, so 1/2 of pi r squared. Okay, make sense? So this one would be, the area of this part would be what? Uh, yeah, 3/4 of pi r squared, and this one would be 1/3 of pi r squared, and this one would be 1/4 of pi r squared. All right. However, let's not forget where the halves and quarters and things came from. So before we actually simplified, right, what did I have before the simplified fraction? Okay, that's what I want to know, because that'll make it work all the time. So instead of having a half here, instead, exactly, 180 over 360. Instead of a quarter, 90 over 360. Instead of 3/4, 270 over 360. And instead of a third, I can have my 120 over 360. Now, do you notice anything that's always the same? Can we try and generalize what we've just done? Right? Is there going to be a formula, for instance, for the area of any sector? Well, we've got the pi r squared bit, right? Is that the same in all of them? Because we're looking at the sector of a circle. So that bit's going to be there. So we've got the pi r squared bit. What do you notice about the fractions? If I haven't simplified, what's the same in all of them? They're always out of 360. I'm going to put that in. Now, the one thing that does change is obviously the angle that in the question I'm working on. So we can't have the same number all the time. So we need a way of saying the angle. And what do we use? Yeah, the symbol for theta. So this is the formula for the area of a sector, which is whatever angle you've got, it's that out of 360. So you can divide by 360. So 90 divided by 360 would have been 1/4. All right, and then we use that and we multiply by the area of a circle because that tells us the fraction of the circle. All right. Sometimes this will give us a decimal value. It will not work nice and easily. I've picked ones that all work nice and easy. So let's have a look. These are some of the questions out of the textbook. All right. So let's have a look at maybe this question here. A sector with a central angle of 140 and a radius is 9. Find the area of the sector. So we're looking for this area. What do I do to find it?
140 over 360 times pi 9 squared.
Yes. Exactly that. All right, and then can you do that on a calculator for me, someone?
I got 98.96.
98.96. Okay. Anyone else confirm? Is anyone doing it to confirm, or you got the same? Okay, so I'm happy with that. 98.96. Our units are square centimeters. Now, just because I can see it coming down here, there is that's rounded, right? Because pi is an irrational number. It's 3.14, blah, blah, blah. So we're always going to have to round our answers, especially if the fraction needs to be rounded as well. So this will be a rounded answer. But we can potentially give an exact answer. So what we'll look at is say, right, instead of giving it as a decimal like this, I'm actually going to give my answer in terms of pi. All right. So what that means is I'm going to do all the numbers. So 140 over 360. I'm going to multiply that by the 9 squared, and then I'm going to have times pi afterwards, and I'm going to leave the pi. So it might not be still accurate in this case, but just to show you, if you do that, just do the numbers, right? This bit here, what do you get if you do that and not multiply by the pi?
A fraction or a decimal?
Up to you.
I got 63 over 2.
Yeah, I can get that. So we could do 63 over 2 pi, like that. Because as well 63 over 2 as a decimal is actually still not a problem, we don't have to round it, we can do 31.5 pi. Okay, so these I could now say these are what we call exact answers, okay, because we haven't had to round them. So I can see in this question here, look, it says 48 pi. And the reason why they're leaving it like that is because we don't want to round it. All right. Does that make sense? It's not particularly difficult, I guess, if you're okay. But let's just have a look at this next one. I put a few questions. Let's see. Let's have a look at this one. So it says a sector with radius 10, central angle x. So the angle is the unknown now. But what we're going to do again is let's consider it the formula again. So we've got the area is the angle divided by 360 multiplied by pi and r squared. So let's put the values in that we know. So do we know what the area is? Yes, we know what the area is. So I can replace area with 48 pi. The angle is the unknown, so I'm going to put x divided by 360. All right. Then I'm going to multiply by pi. Okay. And then I'm going to multiply by r squared, so that's 10 squared. So let's call it 100. Okay. Now this will make it clear, hopefully, why we would sometimes want to leave the angle, the area in terms of pi, especially if we've got to calculate something else. Can you see what we would do now to isolate the x?
Would you multiply on either side?
Yeah, you could multiply by. I wouldn't multiply by 48 because I've already got 48 over here. Say the 360. Right, we've got multiply by 100, we've got multiply, so we would divide to get rid of those. But actually the first thing I would say, guys, is what if we were to divide by pi? That would cancel it out here and here, yeah? And we don't have that number in there anymore. So now I'm left with kind of an easier one to work with, which is 48 pi divided by pi is just 48. Now I've got x divided by 360, but the pi is gone, multiplied by 100. So that's a bit easier to now work with. I don't have to round anything. There's no decimals involved. So does that make sense? Yeah. So what would I do now at this stage? I'd go with multiply again. What would you multiply by? Yeah, let's multiply both sides by 360. Can you do that for me? So that gets rid of that one. All right. So that would give me 100x on this side because 360 is gone. What's 48 multiplied by 360?
17,280.
17,280. Okay. Right. What do we do next then? by, yeah, so let's divide by 100, and we get that x is equal to 172.8. And what is x again? What's the units of x? It's the angle, so it's in degrees. How does that look, guys? Does that look right, or? Yeah, because you see this angle, it's not quite 180 degrees. So we can check the whole thing would be 180. We've got a little bit less. So that kind of makes sense. I'm happy with that. So I can use that to find the angle. The next question here, look, it's the same kind of thing, only you're finding the R value instead. All right, but we put these values in. Now you can see again, they're giving you the area in terms of pi. Because of this step, we can get rid of the pi instead of turning it into our decimal. All right. Any questions on those at the moment? No? Okay, good. Right, we're not going to have too much longer on the next stage, but let's go from that. Let's talk about this. All right. So a segment of a circle is part of the circle but does not originate from the center. All right. So it's just like, so remember this is the center, that's the origin. A segment is when we cut a bit off. So it's like having the sector but chopping the end off. All right. So we would still have certain things like this is the angle. Now, without going through it too much in detail now, could you see a process for which you could potentially find this area? Is there any way of finding the area of that? What would be, I don't want an answer like a definite sort of formula or anything, but just a general process. What would you do step by step? We're using some. Go on.
Would you try to find the triangle?
Yeah.
Try to find the side.
So let's find the area of the triangle. Yeah. What's the formula for the area of a triangle when you've got an angle and we probably know, let's say this is 6. Do you remember what the formula would be? It's the one that you've been working on. So we're talking about this triangle, right? How do you work out the area of a triangle when you know 2 sides and an angle? God, you told me at the beginning of the lesson, you guys, that you kind of understood it all. You were good with it. Not remember the half AB sine theta that you've been working on? Yeah? So that's what you've been using. So we could use the angle, and we've got the angle sandwich here with the 2 sides. So this would be A and this would be B. All right, if it's 6 and 6. All right. So we could use the formula for this to find the triangle. And then we could also find the area of the, which we've just done, sector. Okay. And the area of the sector we've just said is theta over 360 multiplied by pi r squared. And then what would we do with those 2 values once we'd worked them out to leave us with just the area of the segment? No ideas? No? Well, if I go through the process, look, here's my, if that's a sector, if I work out the area of a sector, and then what I do is I cut out the triangle. Yeah, here's the triangle. If I work out the area of a triangle and I remove that, what am I left with? I'm left with the segment. So what I do is I do area of sector subtract the area of the triangle. Okay, so if I do these two things, so that would be theta divided by 360 multiplied by pi r squared, subtract a half AB sine theta. And you don't have to remember that, you have to remember the process. But you've got all these things, these two formulas that you've been working with now. If I just work them out separately and do a subtraction, it's a common thing in maths. You've got two shapes. If you subtract one from another, you're left with a different shape. So you do that with the areas as well. So that's how you would figure out the area of a segment. All right. Does that make sense? Yeah, cool. All right, so what you're going to be doing then is using what we've just done today to answer some more of those questions in the textbook. But of course, you've got your cognitive to do as well. So no rush, but make sure you've kind of had a little look at this. Like I reiterate, guys, the cognitive, what I really want to do is put a grade in for that task on its own into your mark book, because we haven't put anything in this term, obviously, because you've been doing IAs and things. So I kind of want something to go in that we can that will go towards your transcript. So I've given you over a week, and use your books, ask for help, whatever you need to do. Get that done and get a decent grade on it, and then I can put a decent grade in your mark book to go on your transcript. So take the time, work it out. Ask for help if you get stuck. Don't treat it like a test. All right. Well, if we're all good, no more questions, we'll call that a day there.